Hello and a very warm welcome to Science Monitor, your weekly update on what's happening in and around the country in the field of science, technology, research and innovation. With a special focus on India, we bring you the stories that have the potential to change the S&T landscape of the country and impact your life. I'm Aishwarya Kapoor with you. From the genome sequencing of turmeric accomplished by Indian scientists to an upgraded indigenous technology under the Srijan scheme of TIFAC-SIDBI, we have plenty in store for you. But first, let us begin with the headlines. Integrated approach in S&T for sustainable future launched as the theme of National Science Day 2022. An integrated approach in science and technology will help India to emerge as a leader in science. Researchers at IISR Bhopal sequenced the whole genome of turmeric for the first time in the world. The study has also elucidated the position of turmeric in the evolutionary pathway. Srijan scheme of TIFAC-SIDBI is promoting indigenous innovations. Under the scheme, the upgraded RoboPlasma structural cutting system of plasma technologies will make the Indian industries more self-reliant. And air pollution increased in some parts of the country even during the lockdown period in 2020. New facts revealed by a satellite-based study conducted by the Aryabhat Research Institute of Observational Sciences, Nainital. And now the news in detail. India celebrates National Science Day on the 28th of February to commemorate the discovery of the Raman effect by the great Indian scientist Sir C.V. Raman. The day, which popularizes science and motivates students, is celebrated every year under a relevant theme. Recently, the theme of National Science Day 2022 was launched by Dr. Jitendra Singh, Union Minister of Science and Technology and Earth Sciences, at a function held in New Delhi. For more details, let us see our report.
The National Science Day 2022 will be celebrated this year under the theme Integrated Approach in Science and Technology for Sustainable Future. The theme was launched by Union Minister Dr. Jitendra Singh at a ceremony held at the National Media Centre in New Delhi on the 5th of January. This year's theme has been chosen with the aim to promote extended scientific integration among various science and technology organizations and departments to support sustainable development for the sake of humanity. The integrated approach becomes more relevant as we fight the current pandemic of COVID-19. The theme is expected to encourage all the science ministries and departments to work together on a solution-based approach rather than working in isolated silos that limit their scope.
Every year, a theme is very thoughtfully conceived, keeping in consideration the immediate priorities of the nation, of the society, and world as a whole, because India today is also increasingly assuming a global role. And you would have realized that over the last 7-8 years, ever since Shri Narendra Modi took over as the Prime Minister, he has been reiterating at every available forum that we have to come out of the culture of working in silos. And I think gradually now, to come out of silos is no longer only an option or a by choice, it is a necessity. So I think keeping that mood, that spirit, and also the vision of Prime Minister Modi, this theme has been coined as Integrated Approach in Science and Technology for Sustainable Future.
Renowned Indian scientist Sir Chandrasekhar Venkataraman discovered the Raman effect on the 28th of February 1928. He was awarded the Nobel Prize in Physics in the year 1930 for his work on the scattering of light. Sir C.V. Raman became not only the first Indian but also the first Asian to receive the Nobel in any field of science. To mark his remarkable discovery, India has been celebrating National Science Day every year on the 28th of February since 1987. In collaboration with the National Council for Science and Technology Communication, Department of Science and Technology, various motivational and evaluation-based activities are organized on this day in schools, science and technology institutions, and research laboratories across the country. The basic objective of these activities is to spread a message about the significance of science in our day-to-day life and to showcase all the efforts and achievements in the field of science.
I think this is also one of the best of the times to give a push to this theme, because we are going through a pandemic which has not only generated tremendous amount of public awareness about science, about the various technologies available to us, various innovations, but it has also led to integration on its own, which you must have seen over the last 2 years, how the various departments, the various ministries, even various institutions across the country have come together to collaborate with each other in order to ensure the survival of the mankind.
The national awards in the field of science and technology communication are also conferred on this day. Apart from this, SERB Women Excellence Award and Avsar Awards are also presented on this day. The day has now become a platform for science discussions, popularization and promoting innovations to inspire and recognize challenges of the future.
For the first time in the world, researchers from the Indian Institute of Science, Education and Research, Bhopal, have sequenced the whole genome of the turmeric plant. The researchers have identified many genes related to turmeric's secondary metabolism and its defense responses against stress conditions such as cold, heat, drought, and salinity. The research provides evolutionary insights into the medicinal properties of turmeric and also elucidates its position in the evolutionary pathway. Here is a report on this important development.
Turmeric is an important staple in our kitchens, and references to the herb can be found since mythological times. Used as a spice, turmeric has always been recognized for its medicinal properties. There are thousands of studies on the usefulness of turmeric in Ayurveda and even in the modern era. Turmeric is used to prepare antibiotic and anti-cancer medicines. But to date, no study had yielded a reference genome sequence of the turmeric plant. Now, researchers from the Indian Institute of Science, Education and Research, Bhopal, have succeeded in sequencing the genome of the turmeric plant for the first time in the world. The results of their study have recently been published in the Nature Group's prestigious research journal, Communications Biology.
People have been doing research from, so many papers have come out, but they were all focused on, one aspect of turmeric, right? Nobody looked at the genome in totality, right? So this is the first genome sequence of haldi in the world, right? Which provides researcher an opportunity to map their genes on the genome, to see how their genomes are regulated, which have huge implications and applications in improving the varieties.
In view of the medicinal properties of turmeric, its cultivation is promoted under various schemes of the Government of India. India alone produces about 50 species of turmeric. Herbal genomics, which is a new discipline, inspired researchers from the Department of Biological Sciences at IISER Bhopal to understand the genetic structure of the herbs and their relationship with medicinal properties. Researchers sequenced the whole genome of the turmeric plant by extracting DNA from its leaf tissues. They found that turmeric has developed genetic pathways for the synthesis of secondary metabolites such as curcuminoids to sustain itself under various environmental stressors.
After the DNA extraction, we purified it, and using two latest technologies, that is 10x genomics and Oxford Nanopore technology, we sequenced it. We almost generated 130 GB of data. And as turmeric is a triploid organism, so we use the hybrid approach using short read as well as long read, which helped us to generate or to connect a more contiguous assembly.
The researchers identified more than 50,000 genes that encode specific proteins and found 172 genes with multiple signs of adaptive evolution that are responsible for turmeric's medicinal properties. For genome sequencing, the researchers used state-of-the-art sequencing techniques and looked at 4 key genes that are involved in the biosynthesis of 3 important secondary metabolites of turmeric curcumin, dimethoxycurcumin, and bis-D-methoxycurcumin. These help the turmeric plant to adapt to different environments and give it the defense responses against stress conditions such as cold, heat, drought, and salinity.
We found out that the genes which were evolved in this species were mainly responsible for biotic and abiotic stress tolerance responses, which is actually directly connected to the secondary metabolism properties of this plant, and these genes are actually responsible for conferring the medicinal properties of this plant. Also, besides this, the secondary metabolism pathways like curcuminoid biosynthesis pathway in this plant was found to be specifically evolved. Like we found positive selection, gene expansion contraction, and also we found out the evolution origin of the enzymes involved in this pathway.
This first of its kind turmeric genome sequencing will open new avenues for harnessing the herb's metabolites with a wide range of medicinal properties. This will help scientists to develop better species of turmeric and increase the reach and scope of herbal medicines.
The Technology Information Forecasting and Assessment Council, an autonomous body of the Department of Science and Technology, is working to promote MSMEs and indigenous innovations under the Srijan scheme. The scheme is run in collaboration with the Small Industries Development Bank of India, or SIDBI. Under this scheme, Pune-based Plasma Technologies Private Limited has upgraded its RoboPlasma structural cutting system, which will make various industries related to metal manufacturing more self-reliant. Here is a report.
Metal structures are used in almost every field. From giant constructions such as bridges and buildings to industrial structures and equipment used in the medical field. All require structures made of metal in a variety of designs. Metals are molded into different shapes by cutting and welding. And Pune-based Plasma Technologies Private Limited has been engaged in manufacturing state-of-the-art equipment for the same. The company has also the distinction of producing the first indigenous robotic plasma-based steel cutting and welding machine. Now, under the Srijan scheme of Technology Information Forecasting and Assessment Council, in collaboration with the Small Industries Development Bank of India, Plasma Technologies has upgraded its RoboPlasma structural cutting system. The single machine is capable of performing a variety of structure building tasks with precision 2D and 3D cutting and welding.
RoboPlasma structural steel cutting system. It's a journey of robotics that we are doing for last many years, with the idea that we need to automate, robotize, and bring the Indian fabrication, metalworking industry at par to what the world is doing. Now, while doing all these developments, we realized that this development costs are phenomenal. This is where we tied up with TIFAX region. Under their scheme, we got funding to build a highly upgraded system that is now on offer with customers.
The RoboPlasma Universal System is the world's first double work zone with integrated moving enclosure for various 2D and 3D cutting and welding. This machine is capable of manufacturing steel structures up to 30 meters in length as per individual requirements. These can be in the form of I-beams, channels, angles, square tubes, bulb bars, pipes and plates. The highest quality standard components used in the system help it to operate with minimum human intervention. It can efficiently create complex shapes quickly, which traditionally takes a lot of time and effort. With this robotic system, multiple customer needs can be met simultaneously. The universal system will ensure easier and faster manufacturing of metal infrastructure for industries. The machine also saves valuable shop floor space besides reducing the manufacturing cost.
This robotic system is completely software driven. It's a simple 2-button software that operates it. As an operator, you just have to choose what you want to cut, choose the thickness that you want, and press play. Rest of it all gets taken care of by the system, from the material that is pushed in to the robot that takes over the job of cutting. We are going to ensure that the costs are reduced, quality is maintained at its highest level. At the same time, profit is increased not only because of the cost of the cutting that is low or everything has happened at one go, but also because the cycle time of producing a job is reduced more than 1/3.
The RoboPlasma Universal System, upgraded in India under the Srijan scheme, will also help make the Indian steel structure industry more self-reliant. It will also bring precision to the structures that might have been missing earlier. Under the TIFAC SIDBI Technology Innovation Program, Srijan, technical evaluation to encourage MSME-led innovations, is conducted by the Technology Information Forecasting and Assessment Council, while the Small Industries Development Bank of India does the financial evaluation. The program has been catalyzing the scaling up of sector-agnostic indigenous innovations, contributing to Atmanirbhar Bharat.
During the lockdown period in 2020, most parts of the country reported a decrease in air pollution as many economic activities came to a standstill. However, a satellite-based study conducted by the Nainital-based Aryabhat Research Institute of Observational Sciences has shown that this wasn't the case all over India. Let us see a report to see how this study reveals new facts about increased pollution levels in some parts of the country despite the COVID-19 lockdown.
Even as the COVID-19 pandemic adversely affected life in the entire world, the one positive that was seen throughout was the decline in pollution levels in many countries, including in India. Reduced economic activity and stagnant traffic during the long lockdown period resulted in the reduction of carbon emissions, which had a positive impact on air quality. The observations from this period show that there was a sharp decline in air pollution in most parts of India. But according to a recent satellite-based study, a significant increase in air pollution was observed over parts of central western and northern India, contrary to the general trend. The study was conducted by researchers at Nainital-based Aryabhat Research Institute of Observational Sciences of the Department of Science and Technology.
What we have found that some of these pollutants like ozone, CO, NOx they have increased at the higher height. Of course, there has been decrease in the surface, but at higher height, their concentration has been increased. And what we suggest that this is the mainly because of the emissions from the thermal power plant, that coal burning thermal power plants, and our satellite data, because we have used our ground-based observation, vertical distribution using the balloon and satellite, several satellites. And satellite data shows that there has been increase in these NOx and CO level over this region of the thermal power plant.
Led by ARIES scientist Dr. Manish Naja, researcher Prajwal Rawat utilized the UMETSat and NASA satellite observations for the years 2018, 2019 and 2020 and investigated the influence of significant cutoff of activities on the changes in the vertical and columnar distribution of ozone, carbon monoxide and nitrogen dioxide during the lockdown period. The study, published in Environmental Science and Pollution Research, observed that there had been a decline in most toxic gases and pollutants across the country. But in some central and western parts, ozone, carbon monoxide and nitrogen dioxide increased by about 15% during this period. During the lockdown, the concentration of carbon monoxide in high-altitude areas was found to have a consistent increase as high as 31%. There was a significant increase in ozone concentration as well, including in remote areas such as the Himalayas, while coastal cities also saw a minimal effect of lockdown in air quality.
Depending on the chemical environment in the region, even if there is reduction in the CO or NOx at the surface, but ozone will lead to the production. So that may lead to the production of ozone. And apart from that, because ozone layer is at the higher height, so there we have noticed, or we have also shown, there is downward transport or involvement of the dynamics, like transport of the pollutant from different region. That is leading to enhancement of the ozone. So we have seen that at higher height, ozone, CO, NOx, both are showing the increase in these pollutants level even during the lockdown period. So what we also suggest, like considering the situation, it is very important that India is also should plan to make this pollutants observation using the satellite-based sensor which are on geostationary orbit, so that the study can be made for the longer duration of time over the Indian region.
According to scientists, the O3 levels are affected by the complex photochemistry of ozone's precursor gases such as nitrogen oxides and volatile organic compounds. As the concentration level of ozone is chemically dependent on the environment, so ozone levels in the atmosphere can go up even after a reduction in its precursor gases. In addition, atmospheric meteorology and dynamics can alter ozone concentrations as the ozone-laden air flows down from the stratosphere into the troposphere. This is the reason why toxic gases registered an increase, especially in mountainous regions, despite the lockdown. With the identification of high air pollution risk areas through this study, it will now be easier to identify areas of high respiratory health risk.
And now let's have a quick look at some other developments that have made news in the field of science and technology in our segment Science Express. On the 4th of January, Platinum Jubilee celebrations of CSIR National Physical Laboratory were launched, celebrating its foundation day. The two-day function was inaugurated by the Union Minister of Science and Technology and Earth Sciences, Dr. Jitendra Singh, who also released a special commemorative postage stamp to mark the occasion. The Union Minister dedicated CSIR NPL's LED photometry laboratory to the nation and also inaugurated a science exhibition by school students. CSIR's National Physical Laboratory, which is also called the Timekeeper of the Nation, was established in 1947 and hence it has completed 75 years of its establishment. The Union Minister highlighted the role of scientific institutions in making life easier for the citizens and their continued efforts to make the country self-reliant in every field.
The Indian Space Research Organisation, ISRO, plans to execute many important missions in 2022. In his New Year message on ISRO's website, Dr. K. Shivan reflected on the achievements of ISRO in the previous year and informed its upcoming missions. In 2022, ISRO plans to launch EOS-4 and EOS-6 on board PSLV, EOS-02 on the maiden flight of SSLV, and carry out many test flights for the crew escape system of Gaganyaan. In addition to this, ISRO also has Chandrayaan-3, Aditya L1, ExpoSat, IRN-SS, and technology demonstration missions with advanced indigenously developed technologies on board. Dr. Shivan also informed about ISRO's 3 new space missions that are in the pipeline. These include a twin aeronomy satellite mission called Disha, Venus mission, and Trishna, a joint science mission of ISRO and the National Space Agency of France, CNES.
A Swarna Jayanti Fellow of the Department of Science and Technology has initiated the work of developing an indigenous technology to predict and control vapor explosion-induced accidents in industrial boilers. Professor Rishi Raj, an associate professor in the Department of Mechanical Engineering, IIT Patna, is developing this technology using artificial intelligence and machine learning. In the last 10 years, 23,000 boiler accidents have been recorded worldwide, wherein India alone accounts for 34% of global deaths. Thus, indigenous technology for online monitoring and control of the boiling process will help improve the health, efficiency, and economy of boilers used in key industrial and strategic applications. Professor Raj recently demonstrated that the acoustic fingerprint associated with bubbles may be instrumental in decoding the science of boiling. Therefore, he aims to identify the dominant bubble activity features to develop a physics-informed tool for advanced prediction of boiling regimes using a single acoustic sensor.
Chile is taking a huge step forward for its citizens and the world by writing a new constitution in which climate and ecology will play a central role. This will usher in a new kind of governance that will keep environmental concerns at the forefront. The focus of this new constitution is lithium, which is an essential element for making modern-day batteries. Lithium is found in salt waters near the Andes Mountains. For being an alternative to fossil fuels, the demand for lithium has been increasing, and so has been its price and the rate at which it is being mined. Now, Chile is looking at the right way to go about mining to save the environment. A constitutional convention has been set up to make important decisions related to the regulation of mining and the role of local communities in it. The convention will also decide who owns Chile's water and what exactly defines water. A total of 155 Chileans have been elected to work on the new constitution.
And that is all in today's edition of Science Monitor. Keep sending your feedback and suggestions through email. Our email ID is indiascience@vigyanprasar.gov.in. You can also write into us at Vigyan Prasar, A50, Sector 62, Noida 201309, Uttar Pradesh. So we will take your leave now. See you again next week. Till then, stay safe and think scientifically. Bye for now.